Hey, this is Mr. Barr, and this is the Semester 1 Practice Final version B. Here we go. So base add. So that plus that has to equal 11. So 5 plus 6 equals 11. There we go. Once again, this video isn't really going to teach you the whole thing. It's just quick guidance, a little bit of direction. How many times larger is 3,000 than 300? So 3,000 divided by 300 is 10 times larger. How many times larger is, and this one, number 2, that's not going to be on the final. It's just setting you up for the next one. How many times larger is, how many times larger than, this is the one that I've got an error on. Is that. So I do 5 times 10 to the 8th over 5 times 10 to the 3. I can expand it out, cancel out zeros. 5 divided by 5 is 1 with 1, 2, 3, 4, 5 zeros. There we go. Okay, start at 0, 0, go 12 units over, 0, 0, 12 units over, go up. I'm at 9. Find the error. Okay, so 4 to the 7th over 4 to the 5th. Well, it's going to be 4 to the 7 minus 5. 4 to the 7 minus 5 over 1. That should be over a 1. Should be over a 1. Right? Not over a 4. Create the equation for this. Okay, it has a, here's a good point. A rise of 18, a run of 6. So my slope is 18 over 6, which is 3. So my equation is y equals 3x. Y equals mx plus 0 on that one. Let's see. Select all the expressions that are equivalent. Equivalent is a fancy word for the same or equal. So 3 to the negative 2, 3 to the 7th is 3 to the 5th, raised to the negative 2 power. So 5 to the negative 2 is negative 10. There's a ticket, goes underneath, so 3 to the 10th. The other way to look at this is kind of a distribution. It's not a distribution, but it looks like a distribution. So this would be 3 to the negative 2 to the negative 2, which is 4. And 3 to the 7 to the negative 2, which is negative 14. So 3 to the 4th times 3 to the negative 14th. Let's match them up. 3 to the negative 10, that works. Negative 28, I don't see that. 1 over 3 to the 10th, that matches up. 3 to the 4th, 3 to the 14th, that doesn't match up. It would be a negative 14. Right. So here's the equation. I do the work. I get down to 0 equals 0. What does that mean? 0 equals 0. There are infinite solutions since 0 equals 0 equals true. Equals true is true. Find a value for x that makes this work, and then one that doesn't work. So if x is 1, this would be 4 over 16, which is 1/4. If x is 1, it works. So x equals 1 works. Anything else doesn't work. So x equals 2 doesn't work. Number 10. The thing is, it's a proportional relationship. Proportional relationships are y equals mx plus b. So y equals mx plus b, there's the equation right there. None of these are in y equals mx plus b form. Let's solve this equation. I'm going to distribute the 1/2. That's going to give me a 5 and a negative 4. 5x plus 3x is 8x minus 4. Adding 4 to both sides gives me a 32. And then dividing both sides by 8, x equals 4. Uh, 9x plus x is 10x. 10x minus 14. So now I'm going to add 14 to both sides. That gives me negative 30. So 10x equals negative 30. Dividing both sides by 10, x equals 3. This one's not on the test. It's just a setting you up problem. So one bag can hold 12 oranges. How many bags will be needed to hold 192 oranges? 192 divided by 12 is 16 bags. Now here we go. Let's just ramp it up into exponents. One bag can hold 5 to the 3rd oranges. You picked 5 to the 9th oranges. How many bags will you need? 5 to the 9th over 5 to the 3rd. 9 minus 3 is 6, so 5 to the 6th bags. Select all the equations that have infinitely many solutions. Infinite solutions mean that it's going to be the same on both sides, like 0 equals 0 or 2x equals 2x. So 12x plus 8 equals 12x plus 8 after I distribute it. See that distribution that I do right there? Let's distribute, so 6x plus 42 plus 3, 6x plus 42 plus 3 equals x minus 39, there we go, plus plus 5x, right? Negative negative is 5x, so there's 6x minus 39, 6x plus 45. That doesn't work. It's going to be 3x plus 0, 3x plus 0, and this becomes 3x right there, minus 6x plus 6x, so that one does work because that's a 0. And this last one, I know it doesn't work because right there, that's going to become a positive 28x, which doesn't match up. Next one, 30,000 people stayed home, 600 went on vacation, so 50 times more stayed home. Same idea here, but now with exponents 9 times 10 to the 6th divided by 3 times 10 to the 3rd. 9 divided by 3 is 3. 10 to the 6th divided by 10 to the 3rd is 10 to the 3rd, which is 1,000, so 3,000. You can also expand it and cancel out the zeros. Right, here's a statistics one. Remember, these add up to that. This plus this is that. That plus that is that. That plus that is that. Same thing on the going across. Okay, it looks like the intercept, this is going up by 400, so that intercept's at 6800. 6800 is the y-intercept. And here's a good point, there's a good point. I draw on a slope triangle, 4,000 over 4, which is about 1,000, a negative 1,000. And I'm looking at, when I did another video today, I had this at a little bit different, like negative 1,080 or something. They're close enough. Intercept is at 30. There we go. Intercept is at 30, and the slope is m equals 20 over 40, which is 1/2. There we go. So I have a free cell phone and $70 a month, $70 a month, $70 a month. I pay for the cell phone and it's $55 a month, $55, $55. It comes together right there at 5 months. Got $350. Here we go. Here is a system of equations. They're both in standard form. I split them into 2 mini equations and I solve each mini equation and then I plot those intercepts. Same thing here, 2 mini equations. I solve each mini equations and I plot the intercepts. Here, this is actually infinite solutions. It's the same line on top of each other. Matt wants to buy erasers from eBay. So free shipping and 12 cents. Free, so that's 0. That's the intercept, that's the slope. That's the intercept, that's the slope. Only the model for seller A results in a linear graph. What happened? No. That's false. I don't know why I have that circled. Nope. The 2 graphs will not intersect. That's not true. They have different slopes. They will intersect. Seller A will always be cheaper. I don't know. It depends on what I buy. You can only determine which one is cheaper if you know the number of erasers. Okay, so it's just D on that one. 24. Let's see. One is in standard, so I split it. Get the intercepts and plot it. The other one's in slope-intercept form, so I plot the intercept and I go down 3 over 1, down 3 over 1. There's my point. It has one solution at 1, 3, 1, 3. This one, a system of 2 linear equations has no solution. One equation is that. Select the equation that would make this system have no solution. So no solution means that x and y are the same, but they equal a different constant term, the c term. So 2x minus 3y equals 6, 2x minus 3y equals 6. That's infinite solutions. 4x minus 6y equals 12. Well, half of that is 2x, half of that is negative 3, half of that is 6. That's the exact same equation, just not simplified. Letter C is 3y minus 2x equals 12. I'm going to switch the x and the y. 3y, negative 2x plus 3y equals 12. Now I'm going to go through and change all the signs to negative. So that becomes positive, that becomes negative, that becomes negative. Now look, 2x, negative 3y, equals 6 equals negative 12. Now they're parallel lines, no solution. So it's C. It's that one. And then D. D is 3y plus 2x equals negative 6. You can't see what I'm writing. This is D. So 2x plus 3y. No, I'm not going to be able to change the signs and make these guys match up. So it's C. All right, looks like I've got the intercept at 2.5. Yeah, if this is 3, it's somewhere in between 2 and 3, so 2.5. Slope triangle, this is a weird one. So I couldn't find 2 really good points, so I said I took this up to 14.5. So it went from 2.5 to 14.5, so that's a rise of 12 and a run of 6. So 12 over 6 is 2. You would have still, if you'd kind of gotten some points in there, you'd still get pretty close to it. All right, this one is standard form, split them into mini equations, plot the intercepts, split into mini equations, plot the intercepts, comes together at 3, -1. It's only asking for the x-coordinate. The x-coordinate is x equals 3. Have you been someplace? Okay. So 115, 115, 96, 96, 97, 97, 114, 114. 115 people. Yes, Canada. Yes, Mexico. Yes, Canada. Yes, Mexico. It's right there. Put it in. Adds up, adds up, adds up, adds up, adds up. This one is only for my integrated math 1 class. So this is an intercept and a slope. That's an intercept and a slope. So slope-intercept equations. Set the equations equal to each other. Solve it. I got 10.9. I have to round it up to 11 years because I want to have at least you know what? That rounding up thing may not be correct. Yes, I do not know now. Okay, and then the last one. Lines with the same slope and the same intercept will intersect at exactly 1 point. No, those are actually infinite lines or infinite solutions, so that doesn't work. Lines with the same slope but different intercepts, same slope, different intercepts, will intersect at exactly 1 point. No, that's a no solution. That's wrong. Lines with different slopes will intersect at exactly 1 point. That's always true. And 2 lines that have the same y-intercept intersect at exactly 1 point. Same y-intercept, they do intersect at 1 point, but they could be coinciding lines also, which means there would be infinite solutions. So this is sometimes true. That's it for practice test version B. Thanks for watching. Bye.